Alright, those of you that were in class today know that you have already worked with perimeter and area on the coordinate plane with an example that really helped you to discover the ways to find area and perimeter. So we're just going to do a couple of examples to kind of go with that. So first of all, it says plot the points, and you don't have the points, so I'm just going to tell them to you. We are going to have a figure A, B, C, D, E, where A is at -1, 4, where B is at 4, 4, C is going to be located at 3, -2, D is at -1, -4, and E is at -4, 1. Connect these. This is specifically going to ask to find the perimeter. Of course, we could find the area as well if we wanted to, but we're not going to. We're just going to find the perimeter, as it says. This does talk through this kind of step by step as well. You don't really need that much instruction, but B says, are there any sides for which you do not need the distance formula? And the answer to that is yes, A, B. I don't need the distance formula because it is a horizontal line. So I'm going to go ahead and write that down, that AB is equal to 1, 2, 3, 4, 5. So I've already found that side. And I'm going to list it here so I know I've already got it. The reason is it's a horizontal line, so I don't have to find it. I'm not going to write that down, but that is the reason. C says use the distance formula to find the remaining sides. So I'm just going to go in alphabetical order. I've got AB already, so I need to find BC. So we're going to use the distance formula to do that. And it says, does it say to round? It doesn't. We are going to round to the nearest tenth. So BC right here, B is at 4. I'm going to write this down. It always helps me out. 4, 4. And C is at 3, -2. Help me out a little bit more. So BC, I've got 4 minus 3 squared plus 4 minus -2 or plus 2 squared. Okay. I got to get a calculator if we're going to round the nearest tenth. Okay, typing this in the calculator, I get 4 minus 3 squared plus. Typing this in the calculator, I get approximately 6.1 for BC. So I'm going to write that right here, 6.1 about for BC. Alright, continuing through, I still got a couple more CD. I'm going to label what D is. It helps me out. -1, -4. So 3 minus -1 is the same as 3 plus 1 squared plus -2 minus -4 or plus 4 squared. I'm going to round that to nearest tenth using the calculator. Three plus 1 squared plus -2 plus 4 squared. I get approximately 4.5. So this is about 4.5. Keep going, DE. Set it up. I've got to know what E is. E is -4, 1. So negative, make sure it's negative. Yep. -1 plus 4 because it's minus a negative plus -4 minus 1 squared. Typing that in as well, I should get approximately 5.8. So this is about 5.8. And last, AE. denote A is at -1, 4. So -4 plus 1, because it's -1, so 1 minus 4. And that comes out to approximately 4.2. D says find the sum. So 5 plus 6.1 plus 5 plus 6.1 plus 4.5 plus 5.8 plus 4.2. So the perimeter should be approximately 25.6 units. There. So that should be the perimeter on the coordinate plane. I'm just using the distance formula and then adding the lengths together. Next, we're going to talk about area on the coordinate plane. Something you saw in the first thing we did today is that while there are formulas for all of these, you technically don't need all these formulas. This is just a reference. If you were tearing these out of your book, by the way, that one was on page 549, and this one was on page 550. And these are a good reference to have. However, you should be able to, if you know the triangle formula and you know formula for a rectangle, you can divide every other shape into a triangle or a rectangle. So you don't actually have to memorize these other formulas. So like this would become a rectangle and 2 triangles. You got 4 triangles here, you got 4 triangles here, and parallelogram is base times height, just like a rectangle as well. But what I mean by you can divide these up into either a rectangle or a triangle really comes down to the area addition postulate, which we should have or did figure out in the beginning of class today. So area addition postulate states that the area of a region is equal to the sum of the areas of the non-overlapping parts. The area addition postulate. It's very similar to like the segment addition postulate, where the pieces of the segments are equal to the whole thing. It's the same idea there, is that you can take the smaller pieces and add them together to get the entire area. Alright, so we're going to do some examples with that. Now these do specify about whether you're supposed to use the addition postulate or whether you're supposed to subtract. I'm going to explain that a little better in just a second. So number 6 says find the area of the polygon by addition. So that means I'm going to need to break it up into shapes that I know. For instance, triangles, rectangles, those kind of things. So I'm going to color code them as well. I'm going to create this right here. I've got a square there. By the way, if you're cutting this out, it is on page 554. So I've got a square, and I'm going to find the area of that. So the area of this square, I've got 1, 2, 3, 4. So I've got a 4 by 4 shape. So that is 16 units squared. 16 square units. This is the color matching there. Okay. I have a triangle here. This one is also a 4, and it's by 1, 2, 3, 4. So a 4 by 4. The area of a triangle is 1/2 base 4 times 4. Now the reason that the size of the base is because this is actually a right triangle right there. This is a right triangle. And that is 1/2 of 16 is 8. So I've got 8 units squared. Next, let's go to this one. This one is also a right triangle. So we got a right angle right here. And that one is 4 by 2. So 1/2 4 by 2. 4 times 2 is 8. Half of that is 4. So I've got 4 units squared. And the last shape I have there, I have a, grab a different color. I have another triangle, but this time it is not a right triangle. So when I have the height, I'm going to have to create a right angle right there. Let's say that this is the base. So I'm talking about this triangle right here, where I've got the base, which is 4, so 1/2 the base of 4 times the height of 1, 2, 3. 4 times 3 is 12, so half of that is 6 units squared. My final answer, like the addition postulate says, is adding all of these together. So 16 plus 8 plus 4 plus 6 will give me 34 square units. So got 34 square units. The next one is kind of the same. I'm supposed to find the area of the polygon by subtraction, is what it says. Let me focus that. Okay, so to find the area of the polygon by subtraction, what you actually are going to need to do is create a rectangle around the shape. Okay, so I have my rectangle here in black, and I'm going to find the area of that rectangle. And I'm going to write that down as the area of the whole thing, the area of this whole piece. The area of that rectangle, I've got a 7 by 9 rectangle, and that is 63 units. And I want to know the area of the inside shape. So to find the area of the inside shape, I'm going to take the area of this whole rectangle and subtract these 4 triangles from the whole thing. So let's find the area of each triangle. And again, I'm going to color code those. These are all right triangles because they're rectangle. So this one, the area of this rectangle, I've got 1/2, not rectangle, triangle, 1/2 2 by 1, 2, 3, 4, 5, 6. Let me count that again to make sure. 1, 2, 3, 4, 5, 6. Yep. So that is 6 units. Then I will be taking off in a minute. I'm going to find them all before I start taking anything off. Alright, again, right triangle. So 1/2. 1, 2, 3, 5, 3. One half 3 by 3, I've got 4.5 units squared. Okay, keep going. I've got another right triangle. So 1/2. 1, 2, 3, 4 by 1, 2, 3, 4. Okay, so that is 16 in half is 8. And one more right triangle before I subtract from the whole thing. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So 5 times 5 is 25. Half of that is 12.5 units squared. Alright, so what my goal is to take the area of these and subtract from this piece here. So I'm actually going to take and find the sum of all 4 of those triangle pieces. So I have 6 plus 4.5 plus 8 plus 12.5. So all of the extra stuff here, the extra area, comes out to 31 units squared. So to find my final solution, I'm going to do 63 minus 31, which is going to give me 32 units squared. And that will be the final solution for this irregular shape here in black. You could have done this by addition. You could have done either one of them by addition or subtraction. It's good to know that you could do it either way. But there's just a few examples of area and perimeter on the coordinate plane.